I'm Krithika. I lead the cloud product at ClickHouse. Really excited to be here. This is our first Meetup presentation, talking about our story with Iceberg. So real quick, I don't know, I don't want this to be a polling session late this evening, but how many of you are familiar with ClickHouse? Oh, that's good. I'm encouraged now. So yeah, ClickHouse is an open source, column-oriented distributed database. So we've been the open source for over a decade. And our story with, basically this origins of ClickHouse was around the need for real-time interactive dashboarding use cases. And the best way to sort of paint the picture of where it fits in with the broader database ecosystem is to look at the evolution. I wrote my very first application in Java on top of an Oracle database. So that's where it started. And the Hadoop big data revolution led to prominence of data warehousing technologies such as Snowflake, BigQuery, Redshift, and the likes. And then adjacent to this was the transactional database ecosystem. I worked for a transactional database before, so really good for faster real-time performance, but did not work well, and you have massive volumes of data at petabyte scale. So this is where ClickHouse comes in. We've in fact seen a lot more of Postgres migrations to ClickHouse, mainly because they start with Postgres or MySQL for transactional workloads. Sorry, that's an annoying prompt. But yeah, so basically that's where we see more of ClickHouse use for real-time interactive analytics when you start with a transactional store and you can't really push the scale beyond. That's where ClickHouse comes in. So that's been one of the things that we've excelled, which is why we've had wide adoption and popularity in the open source. We've been around for about 10 years, like I mentioned. So if you compare and contrast to other vendors that have been around for just as long or just have been originated around the same time, you'll see that we've had stellar growth just based on the fact that this has been the differentiated value proposition we've had. So 40,000 stars, 7,000 folks, so the numbers talk for themselves. So as for what makes ClickHouse really fast is obviously every database has a native format. Both on the compute and storage layer, we have a native format that makes it more efficient. So your aggregations, computational logic are more efficient by the fact that it's Parquet-like, but optimized to ensure that computation is parallelized to the extent possible. And the compression is something that we pride ourselves in. We've seen upwards of 99% compression rates. So the whole TCO benefit has been one of the other reasons why users prefer ClickHouse over other technologies. So I won't labor the point about unmatched query performance, being a columnar store. It's really good with high insert throughput, supports projections and materialized views. This continues to be a very popular feature, why we've seen more adoption of ClickHouse. And self-contained, supports various data types and distributed by design. And really being a database, we realize we are often a part of a broader data ecosystem. So which is why we've invested early on. Many of these contributions are thanks to the community. We have integrations with Kafka, the different flavors, and we also connect with transactional data stores. The interoperability is super important for many of our users that want to keep a transactional database on the side of an analytical database like ClickHouse. And the focus of this talk, obviously, is the data lake ClickHouse ecosystem. We have, in fact, done a lot in the last few months leading up to the meetup today, which I'll talk about all the work that we've done. So this unification and the way we address sort of the integrated deployments, it helps us sort of federate queries. We support over 80 plus data formats, Iceberg, Hoodie, Delta Lake, see a lot more adoption of Iceberg, clearly why we're investing more in that direction. We support with the various catalogs. It supports the three major cloud providers, AWS, Azure, and GCP. And as for our story with Iceberg, it started 2 years back. We take our PRs as well as feature requests very seriously, as you can tell. So the minute we had a user who is an avid ClickHouse user submit a PR, we took note, and instantly we saw a lot of upvotes on the feature requests and the improvements as well, which is where we accelerated internal efforts to make sure that we are committing to ensuring that some of these use cases are addressed side by side to the ClickHouse use as well. So what we noticed is majority of the use cases was around the usage of ClickHouse alongside Delta Lake, a data lake as a hot-cold layer. So there was this notion of writers that write both to ClickHouse as well as the data lake layer. And then depending on the query, the users redirect their query either to ClickHouse or the data lake layer. So essentially, if you have queries that are on hot data, so recent data, and you have a more complex query pattern, that's where we've seen users use ClickHouse. However, if you're running a query that's on historical data, usually smaller, they then write or read directly from the data lake. So that's essentially what we've seen. But here again, we noticed that the performance was good, not great. So the read as well as the discoverability could be better. So with that, what we did is we said we can't tactically address each of these. Let's step back and think about every single layer and essentially focus on enhancements in each of these, right? Really focus on speed, discoverability, ease of use was the goal here. So we broke it down into optimizations in the query engine, the catalog layer, which is essentially integrations, as well as the object storage. So with the query engine, we didn't necessarily see a lot more work to basically bridge the gap. The work we focused on was primarily on our performance optimization. And the next was the multi-level parallelization, which we already do for ClickHouse native workloads. So we said that's something that we can extend to Iceberg as well. And the advanced caching, really, we've heard several times in other talks today that this is very, very important when it comes to performance. So what we're doing with the query optimization, I mentioned multi-level parallelization. What does this mean? Basically, the node level parallelization is one. We've always seen workloads within ClickHouse scale really well, efficiently when we deploy more nodes, essentially being able to deploy and parallelize at the node level. And at the same time, at the CPU level at each node, being able to ensure that the CPU is optimally used. Same with the core. And the vectorized query execution being a columnar store, this was something that we always did. So we wanted to extend the pattern to the Iceberg integration as well. And last but not the least, invest in more efforts in the caching layer, file system, metadata, and importantly, the preservation of the cache locality. So especially when you're running queries repeatedly, ensuring that they go to the same node, ensure that the responsiveness of the query was much faster. And with that, getting to the catalog layer, this is where security and the connectivity comes into play. So really, as of now, we've integrated with Unity, Polaris, and Glue. This is, again, taking the lead from our community, seeing where the demand is. So this was top of mind for majority of the users. So that's where we invested our efforts. And we also support REST, credential vending, the native RBAC. We have a pretty sophisticated RBAC within ClickHouse, but we wanted to also make sure that we build something custom for the catalog, as well as making sure that only users that are allowed to have access to specific catalogs, specific tables, they can do that efficiently on top of this architecture. And of course, support for S3, GCS, and Azure Blob Storage. And as for the optimizations of the object storage layer, so of the different file formats, we did see Parquet be the emerging standard. I know there's differing opinions on this, but really we double down on efforts on the Parquet format. And this is a visual of a Parquet file. Really, what I wanted to cover here is talk about the structural improvements that we're making. We have a new Parquet reader coming up in the next quarter that will enhance the behavior of how you access data. Basically, when you're reading from object storage, there is latency of the order of 100 milliseconds. So we realize some of the improvements that we're making with the caching and the access, as well as improving the reader, will essentially mean that the throughput is much better. So in this visual representation, I'm sure many of you are familiar with the structure of a Parquet file. You have row groups, column chunks, pages, and the use of statistics and Bloom filters is where we've really seen the throughput. So you're basically looking at which files to, I should have not done the animation, but anyways. So basically, if you were to zoom into it, so relying on partitioning techniques and pruning techniques to see which files to parse really translates to throughput performance improvements. So you're able to pick and choose which files to query versus skip. And there's one more. Anyways, this didn't render itself, but really that's where we focused on making sure that the use of advanced statistics, Bloom filters, further improve these storage level optimizations. And the last but not the least, we do have snapshot support. Time travel is coming. We support V1 and V2. We're one PR away from fully being compatible with V2 with equality deletes. But the next for us is to focus on V3 compatibility. There was mention of the geography and the geometry data types. So that's something that we've seen a lot of interest given ClickHouse and its analytical use cases. This has come up several times. So we're looking to prioritize that. I think this will really open up new use cases for us. Deletion vectors, table encryption. We have some of these already as a part of the core ClickHouse ecosystem, something that we want to make sure that it's best in class when users integrate with Iceberg as well. And yeah, the new Parquet reader, super excited about what's to come with that. I did link our open source roadmap repo if anyone wants to go check out outside of Iceberg, all the work that we're doing to better integrate with data lakes. And we do also have a waitlist page, which actually gives you the choices different. When we started, I think we didn't know where was the center of gravity. Is it Iceberg? Is it Delta Lake? Now, I don't think that's relevant anymore, but still, we still want to understand what the usage patterns are. We've seen from time to time Hoodie come up, but we want to really see demand before we invest that direction. There's a community Slack. We take a rotation within the company, so you'll hear from one of us before the end of the day if you have a question. But yeah, please let us know what's of interest, especially with the catalog integration. The 3 that we've established is fully functional. We are looking at where to expand to after. That's the end of my rapid talk. So, any questions?
You spoke about getting 99% compression. Right? Can you talk about what is the range of compression you've seen from different implementations? Like, is it, like I want to understand.
Yeah, actually, that's a really good question. So it depends on the use cases, what you will always hear, but we have published case studies, both on benchmarks and performance, as well as compression based on the data types that we use. I mean, again, we have JSON, which we recently introduced. That is something that we're working on. But if the data format is possibly, we have published benchmarks on how each of those would look like. Pessimistic would be 80%. We see in the range of 90 plus, 99%.
Another question. Can you just for better understanding, an example of a use case which did not work well with, let's say, many of the other data stores, but was fit for ClickHouse?
I would say the speed and data and where we've seen it help. First, why we don't the use of ClickHouse for transaction databases. Because they have petabyte scale, so it's just of the scale of any other database. So that's one. Let's see. I don't want to dismiss the competition database. Snowflake obviously has its benefits, but at stage and volume, so that's again compromises. At the end of the day, it's the openness also lends itself.
ClickHouse is the columnar vertical or horizontal? What scale it is following ClickHouse data?
Vertical or horizontal? Basically, the compression is done at a column level.
Oh no, the database it was designed the columnar data, right?
Yes.
Yeah, and it is a vertical or horizontal. Like when it go to the Snowflake, they are going to give the multiple vertical warehouse environment.
Oh,
right?
okay.
So,
You mean scaling?
Scaling.
Yeah, we can actually do both. So while we originally envisioned this to be vertically scaling is where you get the most input. We see interesting patterns where combination of things you upfront scale, the parallelization sort of It really depends on the workload, but we support both vertical scaling as well as horizontal scaling.
Oh, cool.
What's been your experience in performance comparison with the cost native format versus Iceberg? And then second part is like, have you been able to attribute that to any part of the Iceberg stack? Is it metadata? Is it parquet layer? Is it object storage latency? What contributes the most to the difference?
Right. I think it's a combination of all three. Object storage, even for cloud product that we have, yes, we do have a commercial offering. That's where we saw a lot more latency hits. In fact, for a period of time, we were actually seeing the source perform better because of that, which is why we invested more in the caching layer that basically helped with the Iceberg integration as well. We ran some internal benchmarks, but well, I think we said to be third party. I think there's obviously the difference between the two because the formats within ClickHouse makes it more efficient. With Iceberg, it's not as much. But yeah, with all the improvements for the parquet reader, we're hopeful that we'll see as good.
So you're getting close. Would you say you're getting close to native performance with Iceberg?
That's the goal. If you met the creator of the project, that's something that's fanatical about. It has to be just as good. So that's been our North Star, but we'll know once we have the first version of the V3.
How about the integration with the BI tools like MicroStrategy, Power BI, and all? How does it?
Yeah. That's actually one thing that I didn't do. It's one of the things I got to talk about in the four different use cases. BI, real-time analytics, but in one of those focus areas, we have a lot of observability use cases. So we do dashboards on either side. Grafana is almost native. We've got a company recently called Hyperfix that has observability. But yeah, the traditional BI vendors, Looker, the likes are all well integrated.
Any update on like ability to register tables in ClickHouse, Iceberg tables through Iceberg REST?
That's a good question. I think I was asking the PM. By the way, I'm here on behalf of the PM who's more focused on it. So my knowledge is a little dated, but I can find out. Is that something that's we work with the Red Panda team? So
Yeah, it'd be really great. Just
yes,
because the Hadoop catalog is deprecated in Iceberg, and so that's the only real means of having auto sync, between the two.
we'll be sure to check it on. But yeah, it might. I'm pretty sure it's on the open source roadmap tracker. But I'll find out.
One more question. What's the biggest installation you have currently in production? And any benchmarks on queries?
Actually, we have a lot of these published as case studies. The largest installation, I'm just trying to think of the reference that would fit the bill. Let me check.
Yandex.
Sorry?
Yandex.
I don't, yeah, that's not using our, let's see. Now, let me go back to our, if I see it, it'll come to me. Our data warehousing is definitely big, observability as well. We in fact had just so fast. I'll find that for you. I'll know when I see it.
Can you contrast the performance of ClickHouse as a data warehouse versus ClickHouse on top of Iceberg? Do you see any drop in performance? So ClickHouse as a data warehouse versus ClickHouse on Iceberg, do you see any drop in performance?
Yeah, that was along the lines of Jason's question. We are, for reasons that there's latency with logging storage access, we haven't seen, obviously the ClickHouse format, we all integrated, works better. And that's one of the reasons why we made some improvements in the other is the bucket. That will bring us closer.
Do you know at a percentage level, like what is the difference?
Yeah, I can.
Based on bench.
I can share that with you. I'm pretty sure we have that in our internal guidance, but yeah, I don't have that top of mind. But yeah, as these scroll, come to me, which ones are the guest installation? But yeah, we've had eBay, several others. Klaviyo is a really good example. They run their entire MarTech stack on top of ClickHouse. Hanson, everyone familiar with that? The crypto use cases are very, very good for ClickHouse. So we've seen mass adoption in that vertical in general. So that by nature tends to be on average petabytes. So as we scroll, I'm sure something will come to me. I'm just trying to make sure that I don't mention someone that's not referenceable yet. But yeah, we have a conference in a couple of weeks. Highly encourage you to register if you're interested. We have speakers from Weights and Biases, OpenAI. We'll say if they're a customer or not. But yeah, a few others that will talk about their story. Questions? Thank you so much.